Okay, this is a demonstration of the back end of the Lightning app that I'm writing. I'm writing it with somebody else. This is not the front end of the application. This is just my test front end that kind of walks through some of the functionality. When this launches as a product, it'll hopefully look a lot nicer. But yeah, this is just a basic demonstration purposes front end. So what we have here, I got an instance of Chrome and an instance of Firefox. This represents two web visitors on the visiting our site. So there's like a bit of a chat room. So we'll call this one Alice, this one Bob. We go hello, and yeah, it's just a basic two users in sort of a shared environment as they browse the site. So what you see at the main menu here is it's showing you three different pieces of art that you can select. So what we're going to do is we're going to select this one, so the client can basically enter this piece of art, and so can this one. You kind of traverse into it. So the purpose here is, okay, now we're looking at this art. So this art has a title, it's Crypto Pepe. It's got a description. It's got a Bitcoin address to identify the artist, which is sort of the minimal. If you want to send a message or something like that, you can sign it with that key or whatever. At least this is some reference to who actually created this art, hopefully. And then there's a Merkle root, which I'll talk about in a second. But yeah, what you're seeing here, this is a 8 pixel by 8 pixel piece of art. It's just small, just for test purposes. But these numbers you see here are in fact Satoshi prices for the pixel. So the purpose of this application, yeah, you pay Satoshis and it reveals what the pixel of the art is. So for example, yeah, if we want to go and buy a piece of art here, or it's a pixel here, you can invoice. So that's coordinate 3,2, so it spins a bolt 11, and then I just have this isn't actually connected to the Lightning or C Lightning right now. It's just a mock, so I can just as quickly mark it as paid. So we bought coordinate 3,2 on the grid, and so you can see both clients updated that pixel's now been bought. And yeah, let's buy another one. In fact, let's buy 2 at the same time. So this is going to go 1, 2, 3, and 4. This isn't a great user interface. That's just how it works for the string at the moment. And I'm going to give it a user string. I'll explain that what that is in a minute. But so I'll just buy 2 at a time here, and so it's going to spin another bolt 11, which we're going to pay, and the same deal. Okay, so I'm going to go into this Merkle root thing. So when the artist has submitted a piece of art, they've in fact committed to this being the piece of art that's for sale. What the purchaser might be interested in is whether they're getting authentic pixels when they're buying them. So for example, if we're going to check out an unbought pixel, I believe it's coordinate 5,5. It's one of those up here. So I'm going to look up the info for coordinate 5,5. What it's going to show is a Merkle proof, through the layers of the Merkle tree all the way up to the root, which is A7, F5. That is the same number that gets advertised right up front as the Merkle root that represents the entire piece of art. So what it's showing you here is sort of the leaf of this Merkle tree is something that's not yet purchased. So this is the value that we're in fact going to be purchasing for our 5 Satoshis in this case. And yeah, it's the number which satisfies the SHA-256 of it is that, and then that gets loaded into the Merkle tree and gets proved all the way up. So let's go ahead and we'll go purchase 5,5 here, and we'll give it a user string called hello world, and again I will explain that in a moment. So we go invoice it, and we're going to pay that right away. So there, yep, so we got the green pixel to show up there, and the green pixel showed up there. That's 5,5. So we're going to look up 5,5. So it's going to tell us that it's been purchased, and that's the color. It's that green tone. And so the hello world, this is the string that got submitted with the invoice. So if that invoice is paid, then whoever paid that invoice potentially is the one that gets to choose sort of a string as part of that pixel's metadata for all time, to kind of say like, hey, I was here, I bought this pixel. But unpacking this invoice, now that it's been paid, we know what the pre-image is. So this was the pre-image of this. So this is in fact the number which satisfies this Merkle proof. So the SHA-256 of it is 8834, which was in fact the payment hash on that invoice. Now you might notice this isn't a purely random number. It's somewhat random. At the end, this is all like entropy. There's like 100 bits of entropy. But what you'll see here is there's a 5 and a 5. That's in fact the coordinate. So this junk on the beginning, this just identifies the art. And then of that piece of art, coordinate 5, my highlight's broken in here. Yeah, there we go. Slow computer. Yeah, number 5, and then the color is encoded in. So that's technically a bit of entropy too, like you don't necessarily know the color in advance. Perhaps you could read the artist's mind in a small capacity, but there's enough random entropy in the rest of it to not to be too concerned there. But yeah, so that's basically it. We're using the pixel, the information that you're being sold is in fact the thing which triggers the Lightning Network payment in this case. So that's a little bit more interesting than just a straight up pixel database sale. We're actually trying to couple the pixel to the actual payment, so it's an atomic swap for that pixel. So yeah, just for fun here, I'll invoice the remaining and mark paid, and so we'll get to see the rest of that. So this is Crypto Pepe, so it's just a very basic piece of art. So that's a complete piece of art, and then yeah, you can look up, wrong field. If you want to look up any random pixel, you can find out how that pixel fits into the overall Merkle proof. Okay, so that's what the app does. So if you're not interested in sort of the implementation details, you can stop watching. But just to kind of explain kind of what I got going on here, I just drew a bit of a picture. So that's what these two terminals here are. I'll just kill the app. So first, I got this backend component, which is this box that I've drawn here. This is a Python REST API. And this is sort of the core logic of the entire application. It has an API to invoice pixels and query the state and do all the various operations. It's a single threaded processing queue, and it's very transactional. It necessarily has to be. So it's basically doing all the coordination, and it writes all the image state and stuff about paid invoices and all that to a different database for each piece of art. So if so this director, I gave it as a parameter, but so there's a directory for each piece of art. That's these guys down here, and then and then in each directory, there's a bunch of various .dat files that record all the pre-images and all that. And then so when an invoice when we've got to request an invoice, or we detect that an invoice has been paid, this has to incorporate that into the transactions, to update the state in such a way to reflect that the purchase has taken place. So yeah, this is designed to work with C Lightning. I actually have it mocked out at the moment. This demo I showed you isn't actually talking to C Lightning, but I have a script here that behaves like C Lightning. And it has a bunch of things like for my unit tests. If I want to test an expired invoice, I can just tell the mock to sort of advance the system clock by an hour, so I can see that the invoices have expired and make sure that the logic happens in the right way. So that's the back end. So that's what was running right here. Yeah, so it's starting up on port 5000. But then we have to manage the web clients. I've used Python twisted. So what's happening with the web clients is they're all connecting to this WebSocket server, and then this instance is more or less just caching the art, and it's doing all the traffic direction to notify everybody when a pixel gets updated, and passes through if an invoice is requested, and when it detects that hey, there's new state, it pulls the state back in, updates the cache, and then tells all the clients. So this is meant to not block it all, to keep the clients all very responsive. This necessarily has to block to keep it all transactional. So yeah, like when I start the server, it pulls it in, and then if I were to refresh this page, yeah, so it pulled the state in, and it found out which pieces of art there are. So yeah, this is fairly basic. This is designed to kind of scale horizontally, like I have multiple instances of these various things, and because this is over a REST API, like these don't have to share hosts and that kind of thing. So I could have a fast backend system or whatever, and then like a high memory kind of caching system. Various things, thinking about down the road if I got to scale this. Yeah, I've put some affordances in for that. So yeah, that's all I wanted to talk about. So this is a work in progress. As I mentioned, we are going to be adding a very much nicer front end to this, and hopefully launching our application ASAP. Of course, it's a lot of work. This is a little bit complicated, but yeah, thanks for watching. Thanks for taking interest. Bye-bye.